Hello, welcome myself Professor Amit Fartale, Srinivas Nyan Prabodhini classes, Sinnar. Today we are going to study the second chapter, 12th Science Physics, Mechanical Properties of Fluid, which explained by me, Professor Amit Fartale. In this chapter number second, fluid. What is meant by fluid? Any substance that can flow is called as fluid. The fluid is a phase of matter that includes liquids, gases, and plasmas. So, the properties of the ideal fluid are as follows. If the fluid is incompressible, its density remains constant. Its flow is irrotational, then the flow is called as smooth flow. If the fluid is non-viscous type, then there is no internal friction between the flow of the fluids. Fourth, if the fluid flow is steady, it means that the velocity at every point remains constant. Next, the branch of physics which deals with the properties of the fluids at the rest is called as hydrostatic. Next, the pressure. The normal force exerted by the fluid at the rest per unit surface area of a contact is called as pressure. Therefore, the formula for the pressure is as follows. P is equal to F upon A with the equation number first. Next slide. The pressure is measured in SI unit Newton per meter square. 1 Newton per meter square is equal to 1 Pascal. Therefore, next is pressure due to the liquid column. Consider a vessel which consists of a liquid and imaginary cylinder of the cross-sectional area A, which is inserted in it. Therefore, rho be the density of the fluid and h be the height of the column. Okay. Therefore, the gravitational force F is equal to mg. M be the mass of the fluid, g be the acceleration due to the gravity. As we know that pressure P is equal to the force upon area. Force upon area. Therefore, put the value of F, P is equal to mg upon A, equation number second. But as we know, the mass of the liquid is given by mass m is equal to the volume of a cylinder into the density of a liquid. Therefore, mass m is equal to area into the height be the volume of a cylinder and rho be the density of the liquid, equation number 3. Therefore, equation 2 becomes, put the value of m in equation number 2, we get P is equal to AH rho G upon A. On cancelling the same terms, we get the final equation of the pressure due to the liquid column. Therefore, P is equal to H rho G be the final equation. Okay, next slide. We are going to study now absolute pressure and the gauge pressure. It is also known as gauge pressure or gauge pressure. As shown in the figure, there is a air-water film or water interface. F1 be the force which is acting on upper face and F2 be the force acting on a downward surface. Therefore, x1 minus x2 should be equal to the h, and x1 and x2 be the heights of reference point. This is the reference point. Okay. Therefore, x1 is greater than the x2 as height increasing in upward direction. Height is increasing in upward direction. That's why x1 is greater than x2. As from the figure, F1 be the force acting on a top and F2 at the bottom. By the static equilibrium, F is equal to mg, which is acting on a downward direction as shown in the figure. By the equilibrium condition, downward forces are negative, upward forces are positive. That's why F2 minus F1 minus mg is equal to 0. Therefore, remaining term F2 is equal to F1 plus mg, equation number first. While P1 and P2 be the pressure at the top and the bottom surface. As per the formula of the pressure, P1 is equal to F1 upon A and P2 is equal to F2 upon A. Finally, F1 is equal to P1 into the A and F2 is equal to P2 into A, equation number 2nd. Therefore, the mass of the cylinder in the water or the fluid container, M is equal to the density into the volume. M be the mass, rho be the density, and volume area into the x1 minus x2 be the equation number 3. Next slide. In this, from equation 1, 2, 3, we get P2A is equal to P1A plus rho Ag into x1 minus x2. On cancelling the same term or cancelling the A, we get P2 is equal to P1 plus rho G into x1 minus x2, equation number 4. If x1 be the liquid level, from this figure, x1 be the liquid level surface, x1 should be equal to 0 and P0 be the atmospheric pressure at the x1. Therefore, x1 is equal to 0, P1 is equal to P0, x2 is equal to minus h downward direction, that's why minus negative sign is there. P2 is equal to the total pressure, that's why equation 4 becomes P2 replacing by the P, P1 replacing by the P0, and remaining term rho G as it is, x1 minus x2, x1 should be equal to 0, x2 minus h minus again plus. Therefore, equation becomes P is equal to P0 plus h rho G, equation number 5. Equation 5 gives the total or the absolute pressure at the depth h below the liquid surface. Okay. Next, therefore, the difference between the absolute pressure and the atmospheric pressure is called as gauge pressure. The difference between the absolute and the atmospheric pressure. This is the absolute pressure and atmospheric pressure. The difference is called as gauge pressure, which is given by h rho G. Okay. Now we have to find the atmospheric pressure at the distance small d as shown in a figure. Okay. D be the distance of a liquid column. Okay. So put the value x1 should be equal to d, p1 is equal to p, x2 is equal to 0, p2 is equal to p0 in equation number 4. We get p0 is equal to p plus rho g d minus 0. Therefore, final equation p0 is equal to p plus rho g d. Final total pressure P is equal to P0 minus rho GD, equation number 7. Next slide please. Pascal's law. Now we have to see the Pascal's law. Pascal's law states that the applied pressure at any point, at enclosed fluid at the rest is transmitted equally and undiminished to the every point of the fluids and the walls of a container as shown in the figure. Therefore, there is a experimentally proof from the figure. A vessel consists of 4 arms A, B, C, D, which fitted with the frictionless pistons, okay, and having the areas A, twice A, 3A, A by 2, which having the force F twice F, 3F, F by 2 similarly. Okay. The pressure at the point A, B, C, D is as follows. On A, pressure A is equal to F upon A as per the formula, equation number 1st. Pressure at B, twice F upon twice A, F 2 get cancel. Therefore, final pressure at B is equal to F upon A, equation number 2nd. On the point C, pressure C is equal to 3F upon 3A, 3 get cancel, PC is equal to F upon A, equation number 3. On D, PD means pressure at D is equal to F by 2 divided by A by 2 divided by 2 cancel, 2 get cancel. Final pressure at D is equal to F by A, equation number 4. Therefore, from equation number 1, 2, 3 and 4, it is clear that the pressure at A, B, C and pressure at point D is remains same. Therefore, equation 5 gives the Pascal's law. Hence the equation obeys the Pascal law. Therefore, there is some applications of the Pascal law. First application is their hydraulic lift. As shown in the figure, the lift is used for the lift the heavy loads or the object by the small forces. It's working on the based on the Pascal's law. As shown in the figure, the tanks containing the fluids having the pistons S1 and the S2. Okay, and the area is greater than A2 is greater than the A1. A2 is much greater than the A1. If we apply F1 on the A1, then it transmitted towards the piston S2. Force F2 in a upward direction. That's why F2 is equal to P2 into A2 and P1 is equal to F1 into A1. Be the pressure and the force. As per the Pascal's law, the pressure at every point is remains same. Therefore, F1 upon A1 is equal to F2 upon A2. Finally, we get F2 be the force, which is larger force. F2 is equal to F1 into A2 upon A1, equation number 2. So, the load, heavy load can be easily lifted by the force. Okay, next, hydraulic brakes. This is the second application which based on the Pascal's law. Okay, first, it is used to slow down or stop the vehicles. It is based on the principle of hydraulic lift. As shown in the figure, the systematic sketch for the hydraulic brakes is given. If we press the brake pedal, the master cylinder gives the push forward force to the slave cylinders. In this case, the slave piston pushes the friction pads which is connected to the rotating disc, and this causes the vehicle slows down or to stop. As the master cylinder having the cross section area A1 and the slave area for the A2. Okay, therefore the forces and the pressure at the cylinder A1 is given by P1 is equal to F1 upon A1, equation number first, and the transmitted pressure towards the slave piston is P2. P2 is equal to F2 upon A2. By the Pascal's law, the pressure at every point remains same or equal. Therefore, P1 is equal to P2. F1 upon A1 is equal to F2 upon A2. Finally, what we get, F2 is equal to F1 into A2 upon A1, equation number 3, which is similar to the principle used in the hydraulic lift. Thank you. For more videos, subscribe our YouTube channel, or this is my WhatsApp number, Professor Amit Fartale, 9767393575. Thank you.